Okay, we're going to do a quick refresher on how to balance equations. And looking at this assignment, we have a very complex equation that we have to balance. So what I did is I went ahead and put each of the individual compounds into the boxes. I counted the atoms. And so now I have to worry about the coefficients. But just a quick run through on how I got the atoms. Okay, if you notice here, if there's not a number, it's understood as 1. And so this 3 distributes and makes it 3 times 1, giving me 3 nitrogens. This 3 distributes times 4, giving me 12 hydrogens. 1 phosphorus, 4 oxygens. For this one, it's going to be 1 lead. And then this number right here, the 4, will distribute inside the parentheses. So 4 times 1, making it 4 nitrogens. And then 4 times 3, making it 12 oxygens. On the other side, we have 3 leads. And then we have the 4 that will distribute inside, making it 4 phosphorus and 16 oxygen. And then for this one, the ammonium nitrate, notice that nitrogen is in 2 areas within the same formula. So we only need to show it once for the symbol, but we need to indicate that there are 2 nitrogens. So we would show 2 nitrogens and then 4 hydrogens, and last but not least 3 oxygens. Okay, so now as we're getting ready to balance them, we're going to start with our metals. Lead is a metal, so we notice that there's 3 here and 1 here. So we're going to go ahead and make this into a 3. To do that, we choose a coefficient of 3. We're choosing 3 because if we multiply 1 by 3, that'll make it the same. So we're going to put a 3, and then that multiplies with that 1 to make 3, times 4 to make 12, and times 12 to make 36. Okay, now that lead is out of the way, we look for any more metals, which there are not, and then we start with the nonmetals. Remember, oxygens and hydrogens at the end. Okay, so we've got this nitrogen, and we got a phosphorus. I'm going to go ahead and do the phosphorus first. It doesn't matter which one you do, but that's the one I picked. Okay, so there's 1 on the side of the reactants and 4 on the side of the products. So to make this into 4, I'm going to multiply it into 4. So that's why I'm going to choose 4 as my coefficient. This 4 will multiply with all the numbers inside the box. So that's going to make it 12 nitrogens. 4 times 12 is 48 hydrogens. 4 times 1 is 4. And 4 times 4 is 16. Okay, so now that those that phosphorus is out of the way, because now they're both 4 on both sides, I'm going to look at the other nonmetal, which is nitrogen. For the nitrogen, there's 12 and 12, making it a total of 24 nitrogen. So I'm just going to write it to the side just to keep track of that. So there's 24 nitrogens on the side of the reactants, and that's how many I need to have on both sides. Okay, so if I look at the nitrogens here, you're going to notice that there are only 2. So for me to go ahead and make it into 24, I'm going to put a 12. By putting this 12, it multiplies with everything inside. So that makes it 12 times 2, which gives me 24. 12 times 4, which makes it 48. And 12 times 3, which gives me 36. Okay, so now the nitrogens are balanced. At the end, we have our hydrogens and oxygens, so I'm going to look at the hydrogens. Okay, the hydrogens show that there are 48, and on this side of the equation, there's 48, so hydrogens are good. Now I look at my oxygens. There's 2 oxygens on this side, so what I do is I add the 36 and the 16, which I have here, because I want a grand total of it. Okay, that's going to give me 52 oxygens. Okay, if I look on this side, I have 36 and 16. So 36 and 16. Okay, that's going to give me a total of 52 as well. So those are balanced. If we look at all the other elements, you're going to find out that they are all balanced and that they all have the same number of atoms on both sides. So now all you have to do is you're going to go ahead and place your coefficients in the lines. So this 4 will come here, this 3 right here, this 1 right here, and then this 12. And now it is balanced.